Okay, so as I mentioned the last class, we need to do a couple of classes of some stuff that will allow us to do everything else in this class. Right? And again, I am the first to admit that they are not necessarily the most enjoyable of classes, but they are necessary classes. I will go over, for those of you who I have graded already, what your grades are, what they mean, right, how you can improve, right, etc. So if you have any of those questions, don't worry. All things will be revealed in the fullness of time. Half of today's class is going to be spent going over the rest of the geometric objects that we need, right? And the other half of the class, right, or at least a chunk of the class, will be then devoting those material or those educational resources, those skill sets, those new skill sets, right, to doing something that hopefully you guys will find significantly more interesting, right, but also will be basically foundational for hopefully what you do for every drawing related thing that you do in the future. So it's a good class, right, in terms of introducing not only new information, but also a new process. Okay, so as I mentioned last week, right, what we're going over, right, is right graphically this shape so that we could then use it as a way of creating this shape because of their interrelationship with each other. And then dimensionally dealing with this shape, right, as it relates to the three-dimensional cousins of these guys. Today we're doing something very similar, right, in the sense that we're taking that shape and then using it as a guideline to create this shape, and then the related shapes that we get geometrically out of the combination of all of those things. Okay, so today I swear to God, or it will be the last time that I ask you to draw geometric shapes, but we got to bludgeon through that for a little bit longer just yet. Now, when we deal with a circle, right, in perspective, what we're dealing with, what we're dealing with, mute, mute.
You muted the wrong version, Jay. We can't hear you at all. There's like three.
I muted myself. Oh, the irony. Okay. When we're dealing with a circle in perspective, it's easier to think about initially to get it across like the general sense of like the thickness, if you want to put it that way, of a circle in perspective when we think about it in relationship to a square, because that circle is going to touch or interrelate with that square at what are called four tangent points. Now, the reason that it's easier to deal with a circle in perspective is that, or sorry, a square in perspective, is that we've got a really academic way of figuring out how to do that in terms of creating a circle or a square in perspective, which means we've got a very clear way on telling whether or not that thing is right or wrong. Whereas if we try to put an ellipse in perspective, it's a little bit more touchy-feely in terms of trying to figure out exactly how thick that ellipse is going to be. One way of thinking about that, right, is that if you had a coin, right, and at one end of the spectrum and the other end of the spectrum, you're looking at the heads and tails, those things would be perfectly circular. If you flip that coin, right, and we're looking directly at the flat edge of that coin, all you would see is the edge of that thing. In between those two spectrums, or those three spectrums, what you have is potentially, anyway, a potentially infinite array of ellipses that gets gradually fatter as you get further and further away from the horizon line, whether or not you're going above or below. And this is what I mean by the touchy-feely aspect of stuff. How do we know which one of these two things is right? Depending on its proximity to our eye level or horizon line. Turns out that it's just a lot easier to figure out how a square in perspective looks depending on how close or how far away it is to the horizon line than it is to an ellipse. And you can basically use that as a way of guesstimating, so to speak, about how far away one thing or one ellipse is from the horizon line versus another. So this will go a certain amount of ways, right, to answering the question that I'm sure has just been keeping you up at night since last week. How do you find a perfect square in perspective? Well, wait no longer, acolytes. The answer is soon to be revealed. Okay, so as I remembered as I said last class, you can start drawing a perspective object in any way. Right? Last time when we were drawing a 1-point rectilinear object, I asked you to draw the front of that object, right? But that's not necessarily the only way to draw it. We can draw the bottom of that object, right, in much the same way that we started off by drawing, right, our pyramidal or triangular bases by finding the recessional lines and then establishing the front edge of what will be a square, right? This square in perspective, right? So as if it was lying flat on the ground. Now, basically what we did last class, right, is that if I wanted to find the back edge of that thing, right, my suggestion would be, right, at least informally, to guess. Right? If it looks right, it is right, so to speak, right? But now we want to find what actually is a square so that we can put a circle inside that thing. And by finding out what that circle is, then kind of figuring out, right, what the ellipse that's associated with it looks like. So if I take this corner, right, and then attach it to that vanishing point, or I take this corner and attach it to that vanishing point, doesn't matter which way I do it because I'm going to get the same answer. Where that line crosses over these recessional lines here and here, and they should line up across from each other, gives me the back edge of what is now a square in perspective. Why does it work this way? Remember, these vanishing points here imply an object that's at 45 degrees to the audience because this is the way that this thing works because we made it up, which means that all 1-point objects and all 2-point objects are going to line up with respect to each other at the corners and at the centers. Now, given allowances for my shitty drawing, what I now have, right, is the central point of that square. And I know that it's a square because this is the way the system works. Now, the nice thing about this is that if I continue this, like if I continue crossing, taking a diagonal line from that back corner, that will then cross over that recessional line and give me another square. And then if I do that again, I get another square. So you can rinse and repeat this process as a way of getting multiple squares, right, in a perspective field. You know, we're going to be using this compositionally in maybe like 4 or 5 classes from now, right, as a way of achieving certain kind of repetitive patterns, which in turn create, right, certain emotional states inside of a picture. But for right now, all we're interested in is the technical bits and bobs of it. Basically, what I've done here, right, is I've taken a square, or rather, I found a square, right, in perspective, right, by crossing the corners, right, of that thing. And those corners just happen to line up, right, with the 2 points. Or rather, I find the corners by, right, establishing the 2 or connecting them to the 2 points. So that's how you create a square in perspective. That makes sense to everyone? Yeah. Okay, now what I'm also going to ask you to do, right, in your assignment is to create a 9-square grid. So we now know that all of these are squares by duplicating those things. I can duplicate this front square in a couple of different ways. So if I want another square on the right-hand side of it, I can take this distance right here, duplicate it here, and then connect this corner here back to my vanishing point from my recessional lines, and then extend these lines out. So I get another 3 squares. Another way of doing that would be to take this diagonal line and extend that out, and then extend this front line out until it intersects that. That gives me the front corner of another square. I connect that back to central vanishing point, and then I connect all of these lines back again. Right, so I basically just did it in reverse, right, or 2 different ways, but established the same thing. And this gives me my 9 square horizontal grid. Now, does that make sense to everybody? Is anybody confused how I did that?
Makes sense? Nice.
Make sense? Good. Everybody in class is good. Everybody online is good. Fantastic.
Looks like it. Yes.
Sweet. Genii, all of you. Okay. Now we can also do that on a vertical. This is where your station points come in handy. So remember from last class, here are station points. Irritating that that is exactly where I don't want it to be. But of course it is. Remember, your station points are equidistant away from your central vanishing point as your 2 points are. Remember, basically what we've done is we just made a cross, and all 4 points are the same distance away from your central vanishing point. This is important, right? Because I can also do this on a vertical. And instead of using your 2 points, you're going to use your station points. So if this is the front edge of the square here on a vertical, I can take the top or the bottom and connect them to their opposing station point. And when I take a recessional line, let's try to draw these a little straighter, Jay. Back to my central vanishing point. I establish the back edge of a square on a vertical. And then if I repeat that process, I get another square. And if I repeat that process again and again, it doesn't matter what direction I go in, I get another square. Now, for those of you who this maybe doesn't make sense to, right, because for whatever reason, the horizontal one makes a little bit more sense to people than the vertical one, you can always just do this with your piece of paper. Right? Turn it on its vertical or turn it on its side, and you got the exact same thing that I just did there, right, in reverse. Okay, because you're going to have to do both of these for your assignment. You're going to have to create a 9 square vertical grid and a 9 square horizontal grid. So again, if I want to do another square here and another square here, I just duplicate that front distance. And now I just extend those lines through. And you'll notice that all those diagonal lines, right, kind of hook up with the corners, right, of those squares, regardless of where they are. Again, given allowances for my shaky hand. Okay, one way of cheating this, right, for your assignment is that if you plan it correctly, I can then take a vertical square, a vertical distance here that's equal to the horizontal distance there, attach that back, and now I don't have to do anything other than drag vertical lines up from my horizontal grid. I just have to duplicate and triplicate my grid. How do you guys feel about that? Okay,
Looks
now,
like they're feeling good.
great. Okay, now the reason that this is important, right, is that a square that exists here is going to be a lot thinner than a square that exists here. And because you now know how to find a square, right, we now have an idea of how to find the ellipse that's associated with that square. Right? Because this finding of the square is very technical, the finding of the ellipse, again, not so much. I'm going to screenshot that for you guys because we're going to move on. Before I move on, do you guys have any final questions about the square? Actually, don't worry about it because we're going to go over it again, so it doesn't really make a difference. Okay, so I'm going to copy this because I'm lazy. And I have the technology in order to do so. Smash. No. Okay, now that you've got your 9 square horizontal grid and your 9 square vertical grid, your job is to now, right, you're going to place an ellipse inside of each one of those things, right, for a little bit more repetitive practice, right, but also as a way of kind of developing a bit more of like that touchy-feely aspect towards how to do that. Now, as I mentioned, a square and a circle have a very particular relationship. Basically, when I do this with the circles, I find the center of that circle. If I drag a vertical and a horizontal through the center of that, I establish where the tangent points, right, of that circle and that square are. This, by the way, was a fascination of the medievals and the Renaissance, which is also why Renaissance cathedrals or chapels rather are all have this eerie kind of perfection and harmony and balance to them because every architectural unit in the Renaissance is built upon the basic unit of a circle and a square and then multiplications of those things so that they could have this easy to remember repetitive patterning and building structure. The medievals were fascinated because it was some sort of reflection of the divinity and purity of the God, of the mind of God. So here we are saddled with the same stuff, minus, right, for our godless secular age. Right, so what we do this, right, what we're doing is we're finding the widest section, right, of your circle, which as we all know is the diameter, right, because of your fascination and love affair with math, just like me. Problem is that when we look at a circle in perspective, and imagine that this is my amazing drawing of us looking down at a person that's looking straight at a circle that's lying flat on the ground in perspective. Because our vision comes from a central point, we have what is called a 60-degree cone of vision. And that cone of vision is physically interrupted from seeing the diameter of the circle because the curvature of the circle itself physically blocks out your view of it. And as a result, the widest part of the circle is slightly in front of that diameter and is what's called the visual axis. This is just one way of saying, right, that the circle or that the ellipse is going to feel a little bit fatter, right, towards the front than it will towards the back. Because when I do this, right, and again, it doesn't matter what direction I do it in. When I find the center here, what I found is the diameter horizontally. Just like when I do this, I found the diameter front to back. But your visual axis is always going to be slightly in front of the diameter. How far in front, you ask? Good question. if I take the distance from the front to the back edge of the square and divide that in half, that is your visual axis. Right, so I'm now taking a line straight to there, and now I've developed a contact point there and there, here, and here. So now you know that your ellipse is going to be a little bit fatter and come out that far, so that I can then draw that ellipse literally quadrant by quadrant. Right, as a way of getting a sense of how thick that thing is. So each one of these squares, both vertically and horizontally, is going to have its own visual axis. What I would like you to do is that you are then going to populate each one of these squares with an ellipse. So if you do that from the front, or if you do that horizontally, that vertical or that visual axis is going to be found just like we did that there. If you do that laterally, you're going to use your station points as a way of defining, right, the front and the back axis. Oops, of course. Of course I rotate it the wrong way. You're going to use one of your station points as a way of finding the visual axis from the front to the back edge. Okay, so if I do that here, there's the halfway point-ish, slightly in front of your diameter. And there's your ellipse on a vertical. Obviously, vertical ellipses are going to be useful for things like car wheels, clock faces, etc. Horizontal ellipses are going to be useful for the tops and bottoms of cans, cups, manhole covers, etc. Okay, so those are useful tools, right, to start to kind of wrap your brain around. Now, that being said, I do not expect this to be a dog and pony show of finding a square every single time that you have to draw an ellipse in this class, right? That is not the intention, right? The intention is to kind of get a sense of about how thick should that thing be as it gets further away from or closer to the horizon line. What we basically want is the ability to kind of guesstimate is like, okay, an ellipse that's going to be there is going to be about that thick. Or an ellipse that's going to be here is going to be about that thick. That makes sense. That makes sense. What we don't want is an ellipse that's this close to the horizon line feeling like this, and an ellipse like this that far away from the horizon line. Okay, that makes no sense. That makes no sense. Right, and we're trying to avoid the things that don't make sense, right, visually. Come on, X's pop up on the screen already. There you go. Boom, X's. Okay, now you can draw those ellipses one of two ways, right? You can draw them like I just did, quadrant by quadrant. You can also draw them kind of like you did in your last assignment, where you start to kind of rough in an idea of those things inside each one of those quadrant or of those squares. I would like in your assignment to see you try both. Right, so I want at least one example of both methods of drawing those ellipses, both vertical and horizontal, because they are really useful. Both are really useful skill sets to have. Right, what I don't want to see is this, right, where you draw a square, right, and then you just got that shit right inside of it. I actually want to see these things fitting the characteristics of what an ellipse looks like, so you get the visual practice of feeling what those things appear to be. That right there, ladies and gentlemen, is part one of your assignment. Okay, your assignment is going to basically be three parts. Right. Part one is this. Part two are the rest of the geometric objects that depend upon an ellipse in order to draw. And part three is hopefully what you guys will agree is the fun shit, comparatively, which is the application of this stuff. But do you guys have any questions before we move on from adventures in ellipses? No,
Looks like everybody's good.
everybody's just so fucking smart, aren't they?
Brilliant, really.
Fine. Okay. So once again, and I do apologize, right, because I know that it is a burden, but man, you guys are going to have to now, right, draw a whole bunch more geometric objects because I said so. So we've already done all the pyramids and peaked roofs and rectilinear objects, right? That doesn't mean that any of this stuff changes. Right? Your horizon line and your vanishing points stay exactly the same thing. You are going to draw, so we'll start off with the easy ones. You're going to draw three spheres. And you're going to draw three of them, not surprisingly, A, O, B, just like we were doing last class. Now, this is the easy one because a sphere is a circle and a circle and a circle. So that's easy. Now, however, rather than just leaving them at circles, right, because that would be pointless, and why would I ask you to just draw that? I want you to draw one to the left and above the horizon line, one to the right and below the horizon line, and one either to the left or to the right, doesn't matter, and either to the top or the bottom, right? Of the either above or below the horizon line a little bit. But what I don't want you to do is this. Do not put an object directly in the center, right, of that. Because what I want you to do is then feel out the ellipses that would then act as equators vertically and horizontally for these things, and then darken the portion of the equator that tells me that that one, right, is pushed to the left and above, to the left of your center of vision and to the left and above your horizon line. Likewise, you're going to do the exact same thing with the sphere below the horizon line, where I darken the equator that tells me that this is pushed below the horizon line and to the right of your center of vision. And then you're going to do the same thing that's to the left or the right, just with a thinner equator. And one that allows me to know that it's a little bit above, a little bit below, because that equator is a little bit more gentle. So this one here should be obvious why you're not going to do it at this point, because this is what your equators will look like. You'll just have two flat sections, right, which reduce its geometric depth and turn it into two dimension. Basically, that's a good way of saying that's a shitty place to put a sphere, right, or any object, prospectively, for that matter. Okay, so those are easy. No, you do not have to build a cube around this. No, you do not have to find a square that's associated with those ellipses, right? You can just kind of feel them out. Right? As long as it tells me that this is to the left and above, to the right and below, and wherever it is you decide to put that, that isn't perfectly aligned with the horizon line. Make it sense, huh? Cool. Okay, now you're going to do two of these. You're going to do two cones above and below the horizon line. You do not need to do one on the horizon line because it's the same thing as doing one below, the same as the pyramid was. What I would like to see you do, though, for at least one of these is that I want to see you construct the square, right, in perspective. Find your visual axis. As well as your diameter so you can find the central point. Now your ellipse is drawn according to that square, the same way that we just did all 18 of those things. But just like when we did the pyramid, the central pivot point determines where the peak of that cone is going to be. You can drag it up again to an arbitrary height, doesn't make any difference. Okay, and then when you attach the peak of that cone, you're going to then attach it to the visual axis, not to the diameter. Right, and then you're going to darken the front edge of this one to establish your cone below the horizon line. For the one above the horizon line, you can feel out about how thick that ellipse is going to be, and then establish the central point to determine where the peak of that cone is going to be to an arbitrary height, and then you bring it down and attach it to the circumference of the ellipse. And then darken the lines that allow you to tell me that I'm staring up at the bottom of that thing. Okay, so you got two of those things, A, B. Again, you don't need one below the horizon line or above and below the horizon line because it's the same thing. How's that for you guys? You good? Okay, yay. Oh, je suis fatigué. Okay, now we need three cones that are like this. Same thing. What I would like to see you do with at least one of them is establish the base of that cone. And your visual axis. Draw the ellipse inside that square. And then from your visual axis, take a vertical line straight up from both sides. And then establish another ellipse that's thinner than the one on the bottom. Okay, so you don't need to do them. I don't need you to do two of them, two squares. All I want to see is this curve along that section of the cone there more aggressive than the curve on the bottom. Right? That's what makes those things feel accurate respective to each other. Okay. The easiest way to screw this up, right, is if you do something like this and then you do something like this. Right. That looks wonky. That looks fine. Okay, you're going to do the exact same thing above the horizon line. And again, if that's your ellipse there, when I come up to do the top, I just want to see that ellipse be slightly thicker. Again, it's important to be able to freehand these things just as much as it is to do them academically. So once you've done one academically, I don't need to see it again. I just need to see this difference being accurate. Okay, and then you're going to do one a little bit above, a little bit below the horizon line. So ellipse here, ellipse there, connecting vertical lines. This one confuses people a little bit because you can't see the top or the bottom of the object. All you can see is the curve of the front edge. Okay, so those are going to be your three, and that's AOB. Any questions about those? Okay, now you're going to do three more of those, except you're going to do them on their side. Now, these aren't going to be AOB. This, right, is going to be left, right, middle. What I mean by left, right, middle is if I want to start an ellipse here, when I come to the other side, I want this ellipse to be slightly fatter as it gets further away from my center of vision. Okay, so that would be the one to say be to the left of your center of vision. Do the exact same thing to the right. I don't care whether or not it's above or below the horizon line because it doesn't make any difference. All that matters, right, is that I'm able to see this side of that and that this ellipse is thicker. And then just like above and below, if I had one a little bit to the left and a little bit to the right, I have an ellipse here, I have an ellipse there, but now I can't see either the left or the right side, right, because it's moving away from me on either side of the center of vision. Okay, so that gives you three more of those. Any questions about those? It's basically the exact same thing that I just did above and below the horizon line, just to the left and to the right. So again, if it helps you make sense of it, just turn your page 90 degrees.
I have a question.
Yes.
Hey Jay, is that one that for the ones that are on the side, should those be made with one of those be made with the tangent points as well?
I can't really hear you. One, it's too quiet and it's a little bit.
Do you want one of those?
You might have to come closer.
Yeah, maybe just
Because the mic's around here.
maybe just type it in or come closer.
Can you hear me better now?
Yeah.
For the vertical, or sorry, for the cylinders on their side, do you want one of those to be made with tangent points as well?
No, it's okay.
Okay, thank you.
Thank you. You can freehand them all, Alvin. Yeah, same answer to the same question. Good question. Okay, I think once you've gone through the ellipses, right, and once you've applied it, right, a couple of times here, right, you'll be more than fine. Right, so this is enough. Okay, now you're going to do three more. You're going to do three more that look like this. And this is going to be AOB. These are easy ones as well because the front of that is just going to be a circle. So I'm just drawing a perfect circle for those of you who are fans of the band. And then you're going to find a central pivot point, right? And connect that back to your central vanishing point. And then at a 90-degree angle, take a diameter. That's going to give you a contact point here and here. Connect those 2 points back to your central vanishing point. And then decide where you want a smaller circle to be further away. Okay, so that ellipse or that circle on the back will just be a smaller circle. There is no perspective distortion, right, to that. So that's an easy one to draw. Same thing if I'm above the horizon line. Just a bigger circle versus a smaller circle. And exactly the same thing if you're on the horizon line. Try not to put the circle directly in the middle. Because it'll flatten things out. And there's your 3 1-point cylinders AOB. How you guys feel about that? Good, super good.
I have a question.
Yep.
You might have to come closer.
Can you go over visual axis?
The visual axis. Okay.
Yes, please.
The visual axis is the distance from the front to the back edge of your square. Right, right, divided in half. Right, and that's the contact point, right, of the ellipse that goes inside that square. That makes sense?
Right.
Yeah.
Yeah.
Okay, so that just gives you, right, that just makes your ellipse a little bit fatter towards the front so that it feels accurate, not like a rugby ball. Okay, that is 14 objects in total that you have to do so far. That is also screenshot numero 3. Okay, and I'm going to do the last 3 objects on a brand new fancy piece or a fancy blank file because this is just getting too messy for it to be useful. I know that this thing works in a different way, but I don't know how. Maybe like that? So bad with these things. Hey, yo. It's exciting. Okay. Lastly, for the last geometric objects I swear I will ever ask you to draw. You're going to do 6 times these in 2-point AOB. Now for these, I just want you to guess. right? There is a way, right, to find a 2-point square, right, in perspective. Right? And there's also a way to do that both vertically and horizontally. I don't want to go over it this class because it just introduces confusion rather than clarity, right? We can go over it again, right, at another point, right, when we go over this, right, with respect to creating repetitive environments. But for right now, right, you're just going to have to take my word for it that you can do it. For this, I'd like you to guess. I want you to have 3 cylinders coming off of this vanishing point and 3 cylinders coming off of this vanishing point. Now, basically, what you're doing when you're doing this, right, is if I was to create a rectilinear shape in 2-point and guesstimate what that square looked like, that was on the front of it. What I would end up with, right, is a rectilinear shape like that. Right? And as a result, what I'd also end up with, right, is an ellipse that fit into that rectilinear shape, something like that. And something like that. And then I would be attaching these recessional lines off of their respective axes points back to this vanishing point. I do not want you to draw, right, that box. What I do want you to do is give me a rough idea of, or give me an oval that looks okay. And by okay, I mean if I twisted that right into being perfectly parallel to your face plane, that it would turn into a circle, not some sort of ovoid. Okay, so if you did something like this, right, and attached it back, that obviously doesn't make sense. If you did something like this and attached it back, that obviously doesn't make sense, right? So this is the touchy-feely aspect of it. You're going to do the same thing above and below the horizon line. And yes, all 6 of these objects will also have to be smashed into the same perspective field as the other ones. Okay, and then the exact same thing in the opposite direction. Okay, so there's a lot of latitude here in terms of, you know, getting these things quote unquote right. They should be close. Again, what we're after here is visual accuracy, not second decimal point accuracy. Right, so basically that means if it looks right, it is right. But don't be lazy about it, is also kind of what I'm saying. And hopefully you're kind of getting a sense of like the method behind the madness of the warm-up exercise that I was asking you to do last day as well. Right? This is obviously a useful tool when you're doing stuff like this. Still haven't got one of those drawing gloves for the tablet, which is irritating because my hand sticks to it all the time. Okay, and those are your 6 objects in 2-point for a grand total of 20 objects in a single perspective field for the second part of your assignment. How do you guys feel about that, other than a sigh of existential relief that these are the last geometric objects that you'll ever have to draw, at least for me?
Feeling good? Oh, yeah.
All good?
I feel. Matthew, feel bad.
Why do you feel bad, Matthew? What did you do? Practice, practice, practice. That's all it is. Oh, well, I've already kind of like gone over that drawing shapes is boring, right? So, man, I admitted it, right? Told you what it was going to be. You just have to do it. Grind your way through it, and 20 shapes later, you're going to be done. Because we're going to go off, all right, and do something different now that applies this to things that will hopefully be more interesting for you. So hopefully the boredom will be short-lived for you, Michael. That is about an hour of listening to me yammer on. For this assignment, you can just eyeball it. Right? For me to go over how to draw a 2-point square in perspective on a vertical or a horizontal, I can do it if you guys want, right? But I don't know if it's going to be beneficial, right, for you. And I will go over it at another point. But if you want to hear it, if you want to see it now, I'll do it for you. It's your guys' dime. You guys want to see or no? Yes, good. Okay. Interpreter.
I got a few head shakes in here for no.
I do not want to see this at all.
Get it out of here.
Okay, this will be quick. So, unfortunately, you have to do this by starting to draw a 1-point square, and this is why it's irritating, right? Because whether or not I'm doing this horizontally or vertically, right, I can't draw a 2-point square without having access to a 1-point square. So, if I find the back edge, right, of this thing, what I've also done, right, is found front corner or the center point, right, of that. Now, if I repeat that process, I would then find another square here, right, and its corners would line up with the centers. What you then have right here in the middle, right, is a 2-point square that lines up with the centers and the corners, right, of that thing. Now, instead of those things being 2 points, flip that onto its vertical, right, and those things can be station points. Does that make sense? Right, but also, if I put an ellipse in here, oops, no. If I then make a box here, hold on. You know what? We're gonna take a break, right? Because every once in a while I get stumped, right? And this is one of those moments. Okay, so we're gonna take 15 minutes. Right, you're gonna come back at 1:45, right? And I'm gonna make sure that I know what it is that I'm talking about, right? Before I continue talking about it with you. Okay, so come back at 1:45. We'll go over this real quickly and then we'll go into the more interesting stuff. Okay?
Sounds good.
Cool. Now I am. Thank
Nice.
you. Thank you, Marie. Okay, so that gives me a 2-point square. We know this. Now, what that also gives me, right, is a 1-point square that would then be associated with it at those junction points. Okay. Now the distance from here to here, if I was to make a cube, right, is going to be exactly the same distance from here to here. So you could measure that, right, do whatever it is you need to do, right? That looks, that's pretty accurate. Why are you twisted now? Okay, so that gives me the front of my 1-point cube. And if I connect those lines back, that then gives me the structure of my 1-point cube. Now I'm going to shift over to here to do the same thing with 2-point. Inside there, you have a 2-point cube or a 2-point square. Which means if I drag this vertical line up here, I now have a 2-point cube there. Which means that you would then smush the ellipse right inside that. Like that. And as for making that shape longer, to be more reflective of the shape that I drew in the other example, I would just extend those lines. And it doesn't matter where I stop those lines. Right, because whatever I draw back here is just going to be a wider and wider reflection. Of the shape towards the front. That makes sense? Basically, you got to find a 1-point cube in order to find a 2-point, or in order to find the 2-point. And unfortunately, it doesn't work in the opposite direction. And that's also why I didn't want to explain it, because it's just a bit of a pain in the ass. How do you guys feel about that? Good?
Looks good. Looks like they understand.
Cool. Ewan, right? It was your question. You good?
They say yes.
Great, fantastic. Okay, so moving on. This is arguably going to be, well, at least what I think, right, is one of the more useful things that I think that you'll get out of this course, right, or any other course, right, devoted to drawing, which is dealing with a process. So just as important as it is to, right, to be able to draw stuff, right, it's also important, right, for us to be able to, right, draw stuff according to a process that makes things easier for us, right? This is more difficult than we tend to think about, because this process is literally geared in the opposite direction towards the way that we do things naturally. The way that we do things naturally is because of the way that our visual and psychological system, our perceptual system are kitted out, is that we're very, very good at focusing on a particular, or focusing on things. The problem is that when we focus on things, because of the way that our visual system is set up, is like we can only focus on one thing at a certain time. So I can only focus here or here or here or here, right, at any one time. I can see other stuff, so to speak, right, in my peripheral vision, but I can only focus on, say, the picture of Jack, right, or the picture of Newen, right, or the picture of the other Newen that are literally stacked on top of each other, right, on my screen. Okay, I can't focus on all three of you, right, at the same time, which means that as a species, we are hopelessly detail oriented, which is really problematic when it comes to drawing, right? Because what we'll do is we'll tend to focus on one detail and then move over to another detail and then move over to another detail, right? And those details don't necessarily correspond to each other, right? It's also very difficult to piece those details together, right? Unless you're using a very certain kind of drawing. So what we're looking for in our process, right, is to develop something, right, that moves from something that's really general towards something that's much more specific, right? Something that is really simple towards things that are ever more complex. And the service of doing that, moving from shapes towards gradually, right, developing, right, so that they have a guideline, right, for the details that are going to be associated with those shapes. So what you're going to do for this portion of your assignment is that you're going to design a building for me. Doesn't matter what the building is. Right? It can be a Gothic cathedral, it can be a space station, right? It can be a saloon, right? It can be just it can be a house, right? It doesn't make any difference. But the design of that building has to have all of the geometric objects associated with with its design. Right? So it doesn't matter what orientation or how you place those things, how you include those things into the design of your building, but they all have to be there. That's one of the limitations, right, of the assignment. Now, what I also want to see, right, in addition to the design of this building, is that you're going to go through a process. First stage of that process is going to be what we call the mass shape of an object. Now, as a part of this, I want you to give me an orthographic projection of your building. What an orthographic projection is, right, is it's very common in industrial design, object design, is that all of your vertical and horizontal lines of presuming a rectilinear object are moving 90 degrees to each other. Right? And generally speaking, right, in this type of thing, it helps you visualize what the shape of that thing is, because you get a two-dimensional front, back, side, front, or top and bottom. For purposes of your assignment, all I need is the front, right, and a side. That's it. Okay, so it's a dehydrated version of that. So let's say that this is my incredible design for a building. That could be the front and the back, right, etc. And then in addition to that, I want to see what the side of that thing looks like. That's what an orthographic projection is. Really, really simple visualization of that building. Now, as simple as that is, it's still not the most simple, okay? Because what the mass shape is that it takes the widest section of that building laterally, the tallest section of that building vertically, and then uses it as a way of placing it inside of a box. And then same thing if you're dealing with that from its profile. There's the box that thing would exist inside of. Now, the benefit of doing this is that I want you to then give me 3 views in different perspectives, right, of that mass shape. So because I know what that building looks like from the front and from the side, I can now establish whether or not I want to draw my building like this. Right? Or if I don't like it, if I don't like that view, maybe I want to draw it like this. And if I don't like either of those, maybe it's because I don't like the fact that it's in 2-point, and I actually want to draw my building like this. The point being, in this part of the process, what this allows me to do is compare and contrast between 3 different perspective views of that object, and then decide upon which one I like the best. And ideally, what we're doing is deciding upon the view that we like the best, right? Not only because we like it, but because it achieves certain perceptual effects in terms of how we interpret, right, those objects, right, because of what perspective does to us perceptually, right, psychologically, another way of putting it. Okay, so that's part 1 of your assignment. It doesn't matter how complex your building is, right? What I want to see, right, are 3 versions perspectively of the mass shape of that building, because it allows you to do this really quickly and really easily without, creating a huge time sink for yourself. Okay, that's part 1. Does that make sense to everyone? Okay. Let me give that a quick screenshot. Okay. Once you've done that, I want you to choose one. Let's say that I choose this one. That's the one that I want to develop, right, from this point forward. You do not, just the shape. Okay, that's the whole point of this portion of the exercise, is that you do this really, really quickly and easily. I do not want details or shapes, right, in that portion of the assignment. Okay, so now you're going to choose one, and now you're going to go into part 2 of your assignment. This is where you're going to now start to include all of your geometric objects through a process of subdivision and addition. So I know what perspective I've chosen. Right, and now this is where drawing structurally will become significantly more important for you guys. That's the view I've chosen. And now I want to draw that thing structurally so that I can see the inside and the outside of that thing and how they interrelate with each other. Okay, so that's the mass shape of my object. Now I'm going to start to subdivide that. And so I find the center of this section here so that I can then find the peak of my peaked roof as well as the base of my peaked roof as it moves towards both vanishing points. So I start to subdivide this shape into that smaller shape, those two smaller shapes. And because I also know that the base of my house is a little bit narrower than the top. So I've now basically taken care of this shape, done. And this shape, also done. Okay, so that's a really basic example of subdivision. Now, because of the requirements of the assignment, let's say that I've got some sort of poorly thought out architectural design where on the top of my building, I'm going to have some sort of pyramidal shape. That now takes care of that. Again, maybe I then have some sort of cylindrical shape coming up. That takes care of that. Stacked on top of that cylindrical shape, I then have a conical shape. That takes care of that. And then because of the requirements of this ridiculous assignment, right, I'm going to have this weather vane Sputnik left over, right, coming out the top of my house. That takes care of that. That fulfills all the requirements of your assignment. You can then obviously add stuff to this in more realistic ways, right? Subdivide in more realistic ways. So for instance, like a common subdivision would be subdividing the front of that house right into a door, right? For example, that's recessed. Maybe a window. You're limited only by the amount of time and effort that you want to put into this. You can have more than, one shape, one of each shape is entirely up to you. Okay, I don't want any details, right, on this stage of the assignment. Only the geometric shapes. Okay, so that would be part 2, right, of the process. How does that sit with everyone? Okay, what you're essentially doing, right, with both of these things, the mass shape is providing a guideline for these things that are mass shape, right, for the more specific shapes that are going to comprise, right, the rest of that object. Right, but the mass shape allows you to manipulate that big shape really quickly and easily so that you can experiment with what version of it you might like the best. Then you're going to flush it out with these geometric objects, and those in turn are going to provide a guideline, right, for stage 3 of your assignment. Stage 3 of your assignment, this is going to be pattern and details. Okay, this is where your creativity and effort and line quality start to make a bigger impact, right, on your grades. What I want you to do, right, is convince me that this roof, for example, is made out of a particular material. Right? Is it made out of grass? Is it made out of glass? Is it made out of steel sheeting? Is it made out of corrugated plastic? Is it made out of shingles? Is it made out of planking? Is it made out of asphalt tile, right? Is it made out of grass sheaths, right? Or palm fronds, et cetera, et cetera. So if I take that roof, right, and then I start doing some detail studies, right, of it. First off, what I'm interested in is the pattern that might be associated with, say, shingles or planking. Maybe that planking, right, of that roof, right, is going to be built like this. And then the pattern of it will be maybe they're individual, they're not equally length planks, but we have something more like that. Now, in turn, each one of those planks has some dimensionality to it. So rather than just being a two-dimensional shape, I can then start to turn that into a three-dimensional version of it. But likewise, rather than just being that shape, now maybe I want to put some details right in it. Right, so that starting to get across the idea of wood grain. Maybe giving, right, some flair to how different edges, right, are treated. Yeah. Down to the point where, maybe there's the odd nail. You can stack up as much detail as you want, right, on this. Now, that doesn't mean that every single plank, right, in that roof needs to become this. But what it does do is now gives you a way of starting to make this shape significantly more interesting in terms of altering things like its silhouette. Darkening certain lines, maybe giving them some thickness and some inclination, right, of that detail, but not necessarily doing every single one. What we're doing is mainly implying that there's something in there that feels more realistic than just a two-dimensional shape. Because what is guaranteed, regardless of how you draw it, right, is that this looks way better than that. Right? And this is the drawing object design part, right, of it. Right? Both are important, right? That underlying geometric shape rate is structural stuff. This is detail stuff. And like I mentioned last class, right? Or maybe I didn't mention last class, right? But this stuff here is structure stuff. This stuff here is surface stuff. Both are important, right? They're just important in different ways. Structure, however, is very difficult to change, right? Once you've got details on it, because you basically invested time and effort right into the details, right? And now you've got to spend a bunch of time getting rid of the details in order to change the structure. Easy way of thinking about that is that it's very difficult for me to change my shirt, or it's very easy for me to change my shirt. It's very difficult to make myself shorter, right? Or taller, or fatter, or skinnier, right? Those are structural changes. Changing my shirt, surface change. Same thing with the drawing. Trying to work out the structure first as a way of providing a guideline for details. Now, It doesn't necessarily mean, right, that that's the roof that you have to have, right? You might want to explore a couple of them. Right? So maybe you want to explore what corrugated plastic looks like. Right? Maybe this is the type of roof that you want. Same thing for, say, the chimney and the chimney and the cap. Maybe those things, right, are comprised out of sheet metal. Right? But sheet metal that's, basically just made out of scraps from the yard, so to speak. Ideally, and by ideally, I mean, I don't necessarily think it's realistic, right? But it is literally ideal, right? And, a nice thing to look for is that every surface that you're drawing, right, goes through the same sort of process of exploration, the same sort of research. Now, if you gave me just this, right, that will fulfill the requirements of the assignment up to a certain point, right? And everybody, right, has the opportunity of doing this portion, right, to the same degree of efficacy, right? Because it doesn't really take, right, a lot of, experience with a pencil in order to do it, so to speak, right? And maybe a little bit more experience, right, in terms of visualizing things this way, right? But the geometric aspect of perspective is just that, just the geometric aspect of perspective. Now, if you left it at that, right, you get maybe like 20 out of 30, right, or 15 out of 30 for your creativity and effort, right? Because you haven't done this stage. A good way of judging, right, your creativity and effort, right? As I kind of mentioned last class, is like, think about, right, me talking for about an hour and a half to 2 hours, right, every class. And then you're going to have at least 3 hours of class time to start working on your assignment, should you so choose to. Ask me questions, get feedback, etc. That would be the minimum amount of time that you want to spend on each assignment, unless you can blow through it faster and get it done well. Right? That's entirely, up to, your guys' own facility at this subject. To a maximum of, say, like an extra 2 hours. Right? I wouldn't put in any more than 5 hours of homework into this class. You can get an entirely decent grade, right, in this class, right, with 3 to 5 hours worth of homework work. You can put in less, obviously, but it comes with consequences. We've already gone over the consequences. Right? Line quality is a different matter. Right? Everybody has the opportunity to get full marks, right, up to creativity and effort, right, regardless of their amount of time, the amount of time that they've been exposed to a pencil. People with with more experience on the asset of a pencil have a little bit more, right, of an advantage with line quality, because there's only one way to figure out how to use these things, and that's just through trial and error, and it takes time. So when you inevitably ask me, right, how to improve your line quality, right, my answers will always be divided up into 3 categories. Right. They're all going to be out of 10. First one is control. Right. Can you make your object look recognizable? Right. Does it look like you put time and effort to just controlling the mechanical tool, right, of a pencil, right, or whatever it is that you're drawing with? Easy example of what I mean by control. If I was drawing a square, this is what animators would consider a rough. The lines aren't all perfect, right? They're kind of overlap. They're different thicknesses, different densities, right? But it's recognizable as a square. Come on, you chuggy thing. There. That's fine. That'll get you 10. Let's say you tidied that up and did a much nicer job of it, so that you had the perfect square. That might get you 15, depending on how you do in the other categories. So both of those are acceptable. What I don't want to see is this. Where you've basically just scribbled something out of your head, right, to get it out as quickly as possible, and it doesn't really look like you give a shit. Okay, I don't want to see that. Okay, so that's what I mean by control. That's going to be 10% of your mark, 10% of, or 1/3 of your line quality grade. Another 10, what just happened? Great. Thanks, Zoom. Sorry, my screen just got kicked out. I'm back. I think it's getting into primetime internet usage where I am, and it's starting to be pretty chuggy. This is actually working better than I thought that it would. Why are you not? Oh, there we go. Okay. Second 10 is going to be detail. Okay. Can you make this look like that? Can you make the roof? Can you convince me, right, that the roof looks like a roof made out of a particular material? Now, when you come up with the inevitable question, how do I draw X? My suggestion is going to be to do this. And I will literally tell you to do this. Right? Come on, catch up. Okay. You're going to go to the almighty Google. Okay. And you are going to type in how to draw whatever the fuck it is that you want to draw. And you're going to look at examples from the avalanche of examples that come up. Ugh. Now my face is gone. Oh, back. Great. Thanks. Wow, is that slow? How to draw shingles, for example. Point being is that you're, as this catches up, you are going to have an avalanche, right, of information. You fucking piece of shit.